In the words of the military author Athenaeus Mechanicus in the 1st century BC, the machines used from ships, which some people call sambykai, have no need of description, on account of their being well known to everyone. And I think that each of these is so different that it is often more desirable for them not to come into being at all than to be constructed badly. For those at the siege of Chios making a mistake and constructing the sambykai taller than the towers caused those who climbed up on them to be killed by fire, with them not able to mount the towers and it not being possible in any way to let the sambykai down. Otherwise, the ships would have capsized as a result of the weight built up high upon them, the weight of the load being on the outside. For this reason, along with other knowledge, the engineers who are going to use these machines must not be inexperienced in optics. Hello, and welcome to the video. Today, we'll be looking at the sambyke, a device for raising a ladder up to the walls of a city in a siege. Here's the name in Greek, sambyke, or plural, sambykai. And in the diagram above, we can see an alternative name, sanduke, all in capital letters, above what looks like a crossbar to the left of the upright. Oh, and by the way, I've explained my pronunciation and transliteration of the word in the video description. Sambyke is actually the name of a musical instrument a bit like a lyre or harp, and the siege engine seems to have got this name because of a vague visual similarity to the instrument. We'll see in a minute that this afforded ample opportunity for puns. Later in the video, we'll look in depth at how a sambyke would have been constructed. This diagram is a copy by a 19th century scholar of a drawing in a medieval manuscript, which itself is probably a descendant of an ancient diagram, but we'll find out more about that in a minute or two. First, let's look at a couple of times when sambykai were used in actual sieges. We already heard from Athenaeus Mechanicus about a failed use of sambykai at an undetermined siege of Chios, and we'll look at two more unsuccessful uses. At the siege of Rhodes by Mithridatic VI of Pontus in 88 BC, and by Marcus Claudius Marcellus of the Roman Republic at the siege of Syracuse in 213 to 212 BC. Both of these sieges, like the siege of Chios described by Athenaeus, involved naval as well as land-based assaults, and in all three cases sambykai were used from ships. You may be able to see from the diagram though that this is a picture of an engine for use on land, and the instructions we'll see later on are for a land engine, but descriptions of sambykai in our other sources, especially in the account of the siege of Syracuse by Polybius, make it clear that the basic function of the engine, to raise a ladder to city walls, was the same, even if the mechanism was sometimes different. Let's get right into our first siege then, the siege of Rhodes in 88 BC, and here our source is the 2nd century AD historian Appian. This was an early action of the Mithridatic Wars, fought between the kingdom of Pontus, led by Mithridates VI on the one side, and the Roman Republic and some of its allies on the other, and Rhodes was one of these allies. In the build-up to the siege, the Rhodians successfully surprised Mithridates' fleet and inflicted quite heavy casualties on it, taking about 400 prisoners. So, says Appian, he prepared for a siege. Mithridates began preparing for another sea battle and a siege at the same time, and built a sambyke, a very large engine borne by two ships. This is all the information we get in Appian about the actual construction of the sambyke. We'll hear a lot more from Polybius about the Roman sambykai at Syracuse in a minute, but Appian will tell us more in a second about how it was used. So, some Rhodian deserters pointed out a temple of Zeus on a high hill near the city as a suitable place for lighting a signal fire, and Mithridates hatched a plan of attacking at night, both by land and by sea. His land and naval detachments were to move up in silence, and then when they saw the signal fire from the hill, they were to shout as loudly as possible and attack. But when they advanced that night, they were spotted by Rhodian lookouts, who lit their own signal fires. Mithridates' men thought that this was their signal and shouted, but the Rhodians had been alerted and shouted right back, which deterred an attack that night. So Mithridates deployed the sambyke the next day, when it was met with apparently divine opposition. The sambyke, brought up against the walls where the Temple of Isis stands, was a great source of fear, allowing the use of many projectiles from it at the same time, along with rams and javelins, and soldiers in boats travelled alongside it with ladders in order to get onto the walls by means of it. But the Rhodians waited steadily for this too, until the engine gave in under the weight, and a vision of Isis seemed to rain down a great amount of fire upon it. Now, it isn't clear here what mechanism was used to raise the ladder, but it may well have been the system of ropes and pulleys attached to the ship's masts that we'll hear about in a second from Polybius. Polybius will also tell us about a platform at the top of the main ladder, and we can probably assume that this is the position from which Mithridates' men could use their missiles and so on. Presumably the rams which Appian mentions are very small ones to be able to be carried up the ladder. Just to give an idea of what this might look like, I've drawn this very rough sketch. This is based on what Polybius will tell us. A rope going through a pulley on the mast could be pulled to raise the ladder, and then props could be inserted under the raised ladder to help keep it in place. I've just shown one ship here, but based on Polybius's account, and the fact that Appian talks about the Sambyke as supported by two ships, we'd have to assume that two ships were lashed together, with two ropes, one each attached to each upright of the ladder, and then passing through a pulley on one of the masts each. This would make the ladder a good deal more stable. Anyway, Appian's mention of soldiers in boats alongside the Sambyke with their own ladders will either mean that they use the ladders to move from their boats to the pair of boats carrying the Sambyke, or that they plan to use them to climb from the main ladder to the walls. The latter may be more likely because in the instructions for constructing a Sambyke that we'll see later, there's a mention of a secondary ladder. However stable all this might have seemed, though, the sheer weight of men on it was evidently too much, and it seems to have collapsed. The fact that the Sambyke was brought up to the wall near the Temple of Isis obviously served as a spur for the story that Isis had appeared, raining fire down on the engine. Presumably, the Rhodians were themselves using incendiary weapons of some sort. Incidentally, a Temple of Isis appearing outside of Egypt at this date would be quite normal. Her cult spread throughout the Greek and Roman worlds in the Hellenistic period. So far then, we've heard of two cases where misdesign or misuse of Sambykai led to failure, but now we're going to see a failure through no fault of the attackers, but simply through ingenious defence. This time, it's the Siege of Syracuse, in 213 to 212 BC, and our source is the 2nd century BC Greek historian Polybius. The siege took place during the Second Punic War, and saw the Romans, under Marcus Claudius Marcellus, attack the Greek city-state, which benefited from the exceptionally gifted and creative engineering mind of Archimedes. Now, you may have heard of him using mirrors to create heat rays which burned Roman ships from a distance, but we don't get any of that in Polybius. We will hear about a number of other ideas which he put into practice, though. Anyway, Polybius's account starts with the description of the setup of the Sambykai. In 8 quinquiremes, with their oars removed, those on the right from some, and those on the left from others, and yoked to each other in pairs by the sides stripped of oars, they brought up to the wall the so-called Sambykai, by means of rowing from the outer sides. He calls the engines so-called Sambykai because, as I said earlier, Sambyke was properly the word for a type of musical instrument. Presumably, if these 8 ships were lashed into pairs, there were 4 Sambykai, with one ladder shared between 2 ships in the arrangement I suggested earlier. Now, Appian, if you remember, was hardly full of detail, but Polybius had evidently seen a Sambyke in action, or read a very thorough account of one, and is much more useful. He flits between past and present tense here, almost as if describing Sambykai generally rather than only these specific ones. Preparing a ladder of 4 feet in width, and so as to be at an equal height to the wall when set up at the right distance away from it, also fencing each side of it and covering it over with high shielding, they laid it down flat on the touching sides of the ships, which had been yoked together, making it extend a great way beyond the ship's rams. On the masts, at the higher points, there were pulleys with ropes. Finally, whenever they're near to needing it, with the ropes attached to the top of the ladder, men standing on the stern drag them by means of the pulleys. Similarly, others on the bow, supporting it with props, make the raising of the engine secure. So this was the sort of thing I sketched out earlier when we were looking at the Siege of Rhodes, although looking back on it I don't think I attached my ropes quite high enough on the ladder. These Roman sambykai are also protected with high sides and possibly a shielded roof, although it isn't clear whether Polybius means that the walkway up the ladder was fully enclosed. He then moves on to describing the platform at the top of the ladder. At the top of the ladder is a platform protected on 3 sides by wicker screens, from which 4 men who have mounted it can fight, combating those hindering the placement of the sambykai from the battlements. When they have lent it into position and are higher than the wall, these men, letting down the sides of the wicker screens on either side, mount the battlements or the towers. The rest of the men follow them through the sambykai, with the ladder safely mounted on both ships by means of the ropes. And the engine got this name fittingly, for whenever it is raised, the arrangement of the ship and the ladder put together is just like a sambykai. And here he means the musical instrument. Presumably the ship and the ladder are like the body of the instrument and the ropes are like its strings, although the land version, which we'll see in a minute, doesn't have the same use of ropes, which seems to make the comparison less good. But anyway, the Romans brought up their ships, but Archimedes was prepared. He had a number of artillery pieces of different sizes and in different positions, so as to be able to keep the Roman ships under constant fire from the maximum possible artillery range, all the way up to a position very close to the wall. This forced Marcellus into attempting an attack at night, but even then, when they had got close into the wall, the Syracusans were able to fire bows and scorpions through openings which Archimedes had had them make at various points up the height of the wall, and this made the Roman marines ineffective. He also had something special planned for the sambykai. And when they tried to raise the sambykai, he had prepared engines along the whole wall, invisible for all the time before that, but coming up above the walls from within at the time of need, and projecting far beyond the battlements with their beams. Some of these carried stones no lighter than 10 talents, and others carried lead weights. Then, whenever the sambykai approached, the beams, brought around towards where they were needed on a universal joint, released their stones onto the engines by means of a trigger mechanism. As a result of this, it came about that not only was the engine itself smashed, but the ship more generally and those in it were in danger. Polybius goes on to say that Archimedes' contraptions were especially successful at disrupting the men who had been otherwise well protected behind the wicker screens on the platforms, and also at scaring men away from the bows of the ships, where they were, presumably, ensuring that the supporting props remained in place. Incidentally, talents varied in weight throughout the Greek world, but to give you an idea of the sort of weight we're talking about, an Attic talent was about 26 kilograms, or about 4 stone, so stones 10 times this weight would have had a devastating impact on the Roman ships, if this is accurate. Next, Polybius mentions quite a famous engine, Archimedes' claw, a sort of hook which was lowered and grabbed the front end of the ships. Then it was raised, lifting them out of the water into a near vertical position before dropping them. This made some ships land on their sides, some capsize, and some just take on too much water and sink. Polybius gives a fair amount of detail about the mechanism for the claw, but we won't go into it here. Presumably it was only used on ships without sambykai to avoid the risk of the ladder getting in the way of the claw. But if you're interested in the mechanics of siege engines, I'd encourage you to look this up yourself, and I'll put a link to a translation of Polybius in the video description. The picture on the screen is an artistic imagining of the claw, and it looks really good, but unfortunately it isn't accurate. The claw was actually lowered on a chain. One bit of Polybius' account of the claw at work does deserve a special mention, though, because of the lovely phrasing he uses. When describing the ships taking on water after being dropped by the claw, he says that they became full of the sea and of confusion. That's almost poetic. You can imagine something like, the ships were too damaged now even to flee, full of confusion and full of the sea. Okay, so I may not be winning any prizes for my poetry anytime soon, but you get the idea. Anyway, Marcellus saw his naval assault rebuffed, but still apparently had the wherewithal to make a pun. And this relies on the fact that sambykai can mean a female sambykai player as well as the instrument itself. Marcellus caused difficulties by what had faced him at the hands of Archimedes, and seeing those within brushing off his attacks with harm and mockery, bore the misfortune with difficulty, but joking nonetheless about his deeds, said that Archimedes had ladled wine from the sea with his ships, and that his sambykai players had been flogged and kicked out in shame as though uninvited. So the idea of the metaphor is that we're at some kind of symposium or party, and Archimedes is using the Roman ships as kouathoi, or ladles, to scoop up seawater, which is representing wine in the metaphor. Marcellus has provided the entertainment, as it were, with his sambykai, but they haven't been well received. The last word in the Greek, ekpeptokenai, from the verb ekpipto, literally means to fall out, but it can be used of performers to mean be booed off stage or something like that. For example, in Demosthenes' speech on the Crown, section 265. This is what I've translated as kicked out. Anyway, that's the end of Polybius' account of sambykai at the siege of Syracuse, so it's time to move on to the actual construction of a sambyke. The text we'll be using is called κατασκευασθῆναι, or Constructions, and was written by an author named Biton of Pergamon, probably in the 2nd century BC. His work is addressed to a king Attalus, presumably Attalus II of Pergamon, and describes 6 siege engines, of which the sambyke is one. He tends to end his descriptions of engines with a reference to a diagram that he has drawn. Now, let's look back at that diagram from the beginning. This was copied in the 19th century by Vescher from a medieval manuscript copy of Biton's work, and it's possible that this is a descendant of an ancient drawing, but not necessarily by Biton himself, so we shouldn't be too bound by it. It looks a little strange, because it's trying to be both side-on and from above at the same time, which gives it a weird sort of 3D effect, and also means that some of the components are at misleading angles. There's also another diagram of a sambyke we can find in a medieval manuscript. This time, the text which it's accompanying is a Byzantine military treatise, Polioketica, or Siegecraft, by the 10th century author Heron of Byzantium. And accompanying this picture, he says that Biton describes sambykai mounted on shafts, as in this picture, but whoever drew the diagram evidently hadn't read Biton's work, because the use of ropes to raise the ladder isn't consistent with the description we're about to see. The scale is also a little off. Either the man is huge or the ladder is tiny, but it does show a covered ladder, which may be consistent with Polybius' account of the Roman sambykai at Syracuse. Anyway, remember that these are 19th century copies of drawings in medieval manuscripts, and not the drawings themselves. I put details in the video description. As we go through Biton's instructions, I'll build up a basic sketch of the engine so we can get a vague idea of how it might have looked. You might want to go full screen at points to see them close up. So, Biton starts his description by telling us that the engine was invented by a certain Damis of Colophon. There isn't really any other information about this engineer. Biton flits between past and present tense in his description, so we get the impression that he's both describing how Damis' engine was constructed and telling us how to build one of our own. The first components he describes are the traphex and kilibas, the beam and the stand. There was a beam, and it had in it parallel axles. The axles were furnished with wheels. The diameter of the wheels was 3 feet, and the width of the beam was 3 feet, and its height 2 feet, and its length 27 feet. The height of the stand on the beam was 14 feet. Let the stand be new, fitted firmly, and at right angles to the beam, iron plated in places where this is necessary. Then, through the cross beam of the stand were brought bars in a sort of elbow shape. On the right there, you can see a side elevation and a view from above. So first, there's this beam, 2 feet tall, 3 wide, and 27 long, fitted with axles which hold wheels of 3 feet in diameter. I've made them just under 2 feet in width, but this is just a guess. Marsden, the leading 20th century scholar on siege engines, made them 3 feet wide. There's a full reference, by the way, to his work on the sambyke in the video description. I'll mention it quite a bit as we go. But Biton doesn't tell us the width of the wheels, so we can't be sure either way. Then we've got the stand, with a height of 14 feet, and marked on the diagram with a capital Greek letter nu. In the absence of definite information from Biton, I've made it 3 feet long. Biton doesn't tell us this explicitly, but the stand is going to have to be made of 2 uprights with a gap in between them in which the ladder is going to rotate. I've made these each a little under half a foot, which will allow for a ladder over 2 feet wide if the uprights are at the edges of the 3 foot wide stand. Presumably the 2 uprights could have bars joining them together at various points up them to improve stability. I've also put the whole height of the stand above the beam, but presumably it will have been inserted into holes in the beam for stability. It's unclear whether the 14-foot height is all the material used for the stand, including any overlapping with the height of the beam, or only the height above the beam, or the height from the top of the stand to the ground. Finally, there are these elbow-shaped supporting bars. Marsden suggests something like what I've drawn here, and there's something similar in the diagram from the medieval manuscript, but we've no way of determining specific dimensions. So we'll have to go with this until we get more information. Before we move on, I'll just say something about Greek numbers. These are written with letters, with the first 9 letters, alpha, beta, gamma, delta, epsilon, digamma, zeta, eta, and theta, representing 1 to 9. You can see here, gamma used for 3. Then the next 9 are used for 10, 20, etc. up to 90, and the numbers which aren't multiples of 10 use 2 letters, so here's kappa zeta 27. The next 9 letters are then used to represent hundreds, and so on. Anyway, let's carry on with the sambyke, and the next components are the cochleas and the ergates, the roller and the windlass. And through these and the head of the stand, let there be passed a roller, of which the length is 15 feet and the circumference 19 dactyls, and in place of a socket let there be a windlass, so as to make it possible to turn the roller for the deployment of the machine and turn it back the other way for lowering it. Let the windlass be kappa. A dactyl is a 16th of a foot, so 19 of them are a little over a foot. Dividing these by pi give a diameter of 3/8 of a foot, and here it is, 15 feet in length. Now, it sounds at the start of this passage like Biton wants the roller to be going through the elbow-shaped supporting bars as well as through the stand, which allows us to reposition them at the top of the stand. I'm assuming now that they're attached to the outside of the stand of the beam, because otherwise at this high position they'd impede the ladder which we're going to be putting on top of the roller. Finally, in this passage we've got the windlass. If you're familiar with sailing terminology, you might have a definite idea in your head of what a windlass is, but I'm just using the word loosely here to mean this wheel into which the roller is set, with poles around the edge allowing men to rotate the roller backwards by pushing these poles forwards. I'm imagining the front of the engine is on the right as we look in the top picture. Biton doesn't say whether there should be windlasses on both sides, but Marsden suggests there should be, and it seems sensible to me. It would allow twice as many men to push, for one thing. Let's move on to the next component, the cap, or katakles. Then, above the top of the stand, in and above the roller, let there be placed a double cap, delta epsilon, with an opening put in it for all ladders, not with a great degree of precise hollowing out, but as if created for all possible inserted ladders. To the extent that this is possible, let the length be proportional to the ladder that is going to be received into it, so that when there is a deployment, the portion covered by the opening is about 1/12 of the whole length. Unfortunately, this part of the instructions is much vaguer than the others, and it isn't clear exactly what part is delta and what part is epsilon. I've given 2 different suggestions in these pictures. One thing we can say for sure is that Biton wants the length to be 5 feet, as I've made it in the higher picture. This is because he will go on to tell us that he wants the ladder to be 60 feet long, so 1/12 of that is 5 feet. The bottom picture is a cross-section from the front or back, and I've also added some of those potential crossbars I mentioned earlier for stabilising the stand. I've got the cap inserted into incisions in the roller because Biton makes a passing reference to these incisions later. Marsden has a similar suggestion, but his diagram is a bit more complicated than mine. If you're interested, I suggest you get hold of a copy of his book. I've made my cap a little bit narrower than I'm imagining it to, just to make it a bit easier to see how it's fitting into the roller. It isn't exactly clear in what sense the cap is double either. Maybe Biton is just getting at the fact that it has two sides, in which case the assignment of delta and epsilon in the lower picture may be more likely, but alternative suggestions are more than welcome in the comments. Although Biton doesn't mention it explicitly, there must also have been a way of securing the ladder in the cap. Marsden suggests holes in the cap and in the uprights of the ladder through which bars could be pushed, which seems sensible. The next component, happily, is much clearer. This is the main ladder, which Biton calls a sambyke, even though that's also his name for the whole engine. Then, through the cap next to the roller, let there be passed a sambyke of a length of 60 feet, made to a width similar to that of the cap raised up from the incision in the roller. Then let it be defended on either side by walls, so that the men climbing it can make their ascent onto it with confidence. And, again, let the sambyke be wider towards the top end, so that climbing on it might be easier for those mounting the wall. Remember that Polybius' ladder was wide enough at the top for 4 men, which implies that it was wider here than lower down when it was 4 feet wide. The Roman sambykai described by Polybius actually had a platform on top, and the bottom picture is a slightly 3D-ized view of how that might look. The top picture is a top-down view of a flat ladder with just a widening at the top and no platform. I've not included the side walls on these drawings, but on this full drawing, I have done. I've made the walls about 3¼ feet high just to provide a small amount of protection, while also giving an opportunity for throwing javelins or other missiles up at the defenders on the wall. Just a couple more components to go then. First, the counterweight box, or plinthion. And let the ladder have a box at the position omega, 6 feet all around in width and length. And let the box hold an amount of lead sufficient so as to make this lead a counterbalance for the whole weight of the sambyke. And here it is at the back of the ladder. It isn't clear whether it's also meant to be 6 feet tall as well as long, wide and deep, and Marsden is actually doubtful about this, but that's how I've drawn it. The final addition to the engine is a secondary ladder, the word which Biton uses for which is klimax, but that doesn't in and of itself denote a small ladder, it does technically just mean ladder. Then, at a distance from the top end of the primary ladder of about 6 feet, let a ladder be fitted firmly on the uprights of the primary ladder, and let it have restrained motion. And let it have a length equal to the stand, so that whenever the ladder touches the ground, it should be at right angles to the protruding end of the sambyke, and whenever it has taken on men's bodies, then those engaged in the turning of the roller can effect the prescribed action. Restrained motion seems to mean that the secondary ladder won't be able to move further towards the body of the engine than this 90-degree resting position. And presumably Biton means that it's as tall as both the stand and the beam if it's going to be touching the ground. Let's look at the finished engine then. Here's the sambyke in its deployed position, with the secondary ladder at 90 degrees, ready to be moved upwards to whichever angle will aid mounting the wall. Now let's compare that to the diagram we saw at the start. They're very different, but at least some of that is down to the fact that the person who drew the ancient one is trying to convey multiple angles in one picture. He also seems to have made the cataclase, or cap, very big relative to the stand, and his ergates, or windlass, looks like it might be working a little differently to ours. Overall, though, if you make allowances for the different drawing styles, these are at least recognisably similar engines for the most part. Well then, that ends our look at the sambyke. We've seen it used a few times, although unsuccessfully on each occasion, and now we know how to make one ourselves. Perhaps we could do better than Mithridates and Marcellus. See you again soon.